So this is the fourth lecture of the first week of the machine learning course. The topic is applications of machine learning. This topic is, say, more or less independent of many other topics of the course. It's placed early in the course in this position because for many techniques we are going to talk about, we will refer to applications, and therefore I judge it to be a good idea to introduce an overview of applications early to have something to refer to. So when you open a newspaper today or look on television, it's not unlikely that you can see ads or other programs or articles which announce success stories of artificial intelligence applications. So the question is, how can you make sense of this flood of new inventions that claim that all these products are becoming better because they applied artificial intelligence? I mean, I saw recently announcements of new kinds of AI-focused TV brands. I mean, all the major products within the smartphone area by companies by Huawei, Samsung, Qualcomm, they launch AI-powered smartphones. Even Burger King boasts that their ads are AI written. Some of these announcements are pretty serious, actually, but some of them are just crap. What one could say, at least with some certainty, is that a majority of the real stories, the real artificial intelligence success stories, what you see in the media, relate to the application of machine learning, more or less only. So even if the ads claim its application of artificial intelligence, it's not actually any application of artificial in the broad sense, as we have described earlier this week, but rather a pretty narrow application of machine learning techniques. It still may be very useful, but in order to understand what we actually are doing, I think this is a very important fact. A second pretty certain fact is that out of the many machine learning success stories, a majority of these success stories that announced today relate to image recognition or speech recognition. Maybe there are a lot of different kinds of applications which have been improved, but the source of improvement is that the image recognition in these systems have become better, or the speech recognition. So this is just to give you some sanity check of what is probably going on when you see these ads. Some systems announced may be very broad, may be very broadly using machine learning, very broadly artificial, but it's a minority of the systems. So in order to give you some aid in analyzing what is really going on with respect to application, what I've tried to do on the current slide is to separate what I call general application sectors from what I call specific categories of data analysis. The general application sectors are, I would say, trivial or straightforward. They are well recognized. Medical diagnosis, personalized medical treatments, drug design, driverless vehicles and household robots, personal assistant, recommender systems and navigators, adaptation of communication and social media services, marketing and sales, optimization of technical processes, monitoring and surveillance, financial services, cybersecurity, machine translation. All these are rather common sense application sectors. And when you look at the announcements of progress, of course, always these relate to some of these. Is a little more innovative on this slide is the introduction of what is called specific categories of data analysis, because these categories represent some kind of middle level of analysis, which means that you not only say that you make this really great medical diagnosis system uses machine learning, but you really instead you say, okay, there is this medical diagnosis system using image recognition, or using data mining for large data sets, or using text mining. And then indirectly you say that, oh, in the image recognition system you use machine learning, because that's what's actually the truth. So what I claim here is that it's have more explanatory power to introduce these two levels and explain the relation between machine learning and the general application sectors in two steps. And the 5 categories I here introduce of data analysis: image recognition, which I see as the foremost sector, the category for the moment, given everything what happens at this point. Speech recognition is also very important. Data mining for large data sets is the third. Text mining of large document collections is the fourth. And dynamic adaptation of technical systems is the fifth. In the coming slides, I will try to say a few words about each of these categories. So starting with image recognition, or computer vision, which is another word for it. Image recognition computer vision deals with how computers can be made to gain high-level understandings from digital images or videos. So the area seeks to automate tasks that the human visual system is assumed to solve. So we can say we want to mimic here somehow the human visual system. Not entirely, but partly. So image recognition, in my view, is currently the most successful application domain for machine learning techniques. Many of the real success stories we hear about is coming from this area. Recent advances in medical diagnosis, for example, for different kinds of cancers, and the key components in self-driving vehicles are primarily due to the progress in image recognition. So if we look at some subdomains, we can see what is important. It's important to detect objects. It's important to detect events in images. We also have the issue not only about static objects, but also about moving objects. So actually tracking videos and doing motion analysis. Another part is not just looking at objects and static or moving, but also look at the whole scenes, including many objects, or moving or not. A fourth issue here, which is a growing area, is also how you can work with images, how you can restore images if you have a partially damaged image or a bad image. How can you restore it to a state where it's useful for different purposes? And of course, there are many phases of this kind of system. So of course, that you have to have a good system for acquiring images in the first place, for pre-processing them. A very important part is, of course, feature extraction, because for an image, an object on an image have thousands and millions of features. But of course, it doesn't make sense to all do some analysis on learning based on all these possible features, you have to make some extraction or selection. So then comes the phase of detection. Maybe you have to divide up the image in different parts, in different segments, in order to simplify the work. It comes high-level processing. And finally, in the stage decision making based on what image you have analyzed and found. So speech recognition enables the recognition and translation of spoken language into computer-readable text. In speech recognition, both acoustic modeling and language modeling, language engineering, are important parts in the modern statistically based speech recognition systems. Actually, speech recognition, in my opinion, is currently one of the most, or I would say the second most after image recognition, the most successful application domain for machine learning techniques today. There are a lot of advances reported on personal assistance today. Also, machine translation systems get much more usable. And also for various communication systems, there are speech interfaces that becomes more and more used and accepted today. And I would say that in most of these cases, it's not so much the underlying reasoning about the domains. It's not so much about the true language understanding, but it's rather the speech recognition that has been improved that makes these systems more accepted and useful today. There are two kinds of recognition systems. On one hand, you have speaker-independent system that could be used by any person that happen to use them. Or you have speaker-dependent systems where you actually train the systems based on a specific person's voice. So you tailor the systems and fine-tune the recognition for that specific person. And also related to that, of course, this technology can be used for identifying speakers. So the third category is data mining, or synonymously, data analytics for large data sets. Data mining is a process that is used to extract actionable data patterns from large data sets. Actionable is a pretty important word here, because you don't do this analysis for fun. You do it with a purpose. And many times, or most of the times, the motivation for doing data mining is a business-oriented motivation. And to support a wide range of business decisions could be ranging from operational to strategic. Data mining is primarily applied in weak theory domains to discover new patterns, and is also related to other areas like data discovery, knowledge discovery, business intelligence, data warehouses. These terms and concepts are more or less synonymous. So the data sets analyzed in data mining may be user input to e-commerce system. That's a very important source today of such data. Could be also user input to personal assistants, to recommender systems, to mail systems, and social media. It could be data collected from industrial processes, from production processes. And it could be data collected from online learning systems, where there is a specific term for this, learning analytics. But it could also be large factual, financial, and statistical databases. For speech and for image recognition that we discussed earlier, at the moment, the artificial neural network techniques are preferred as a technique. and has had many successes. But for data mining, still, a variety of different machine learning techniques can apply, and there is no such clear bias on which technique that is most successful at the moment. So the fourth category is text mining or text analytics for large document collections. We still talk about large sets of data, but the last category, when we talked about data mining, we mostly refer to structured data. Here we have just normal texts. So the goal for text mining or text analytics is the process exploring and analyzing large amount of unstructured text data, aided by software that can identify concepts, patterns, topics, keywords, and other attributes in this text data. So text mining needs a combination of natural language engineering techniques and data science techniques or machine learning techniques. Typical document collections targeted by text mining are business-related documents, scientific publications, governmental reports, and news strips. Multiple language issues is a key thing here, because of course when you analyze a topic you cannot just say we will look at articles in English, in Chinese, in Japanese. You have to handle the multiple languages. So therefore also machine translation issues are crucial in text mining. Many applications need incremental text mining for new documents to augment knowledge-based systems, expert systems. So for example, you have an expert system in medicine, in law, for example, if those systems gets old after a while. There comes new information all the time in document form. And in order to keep the systems up to date, you actually need to extract the relevant new facts from the new document and augment the systems based on those facts. So the last category of data analysis here I call adaptive control of technical systems. I mean, it's actually a different species of a technology we talk about here. Because adaptive control is the control method used by a controller which must adapt to a controlled systems. And the parameter of the systems are typically uncertain in the beginning of the process. But of course the purpose is during the process to set values on the parameters to acquire an optimal solution. Analytic adaptive control methods are of course focused on truly optimal solutions and algorithms for the exact computation of those solutions. What machine learning can contribute with here are methods that can function and create good solutions even if optimality cannot be guaranteed. And the most relevant machine learning technique in this context is reinforcement learning, which then actually can function in an absence of a mathematical model in this case. One example of this is robot learning, which studies how, for example, a robot can acquire new skills or adapt to an environment during learning activities. So reinforcement learning really looks into how software and hardware agents take action in an environment so as to maximize its capability. Of course, it's needed that the results of earlier actions are systematically logged or documented so that these outcomes can then be fed back into the system to allocate some kind of credit or blame to earlier actions, and modifying the rules of the system and thereby optimizing the future performance. So, having presented these 5 categories of data analysis that all are dependent on machine learning or data science, statistics, I now want to make one example to advocate that this way of analyzing things have an explanatory value. So just look at medicine and applications in medicine. And what I do in this slide is I try to exemplify that in medicine you can have applications of all these 5 categories. That makes sense. So you can have one application in medicine where you actually use image analysis for diagnosis of breast cancer. That's what you do. And you can have a great success in doing this. The second example is in medicine, it's a big issue how to efficiently file medical records in clinical work. And to have a really good speech recognition system that helps doctors and nurses to file the file medical information in the records in an efficient way is a good help. And that is another kind of application. The third application is to use data mining to explore all large clinical databases that exist to find patterns. But still, clinical databases are structured data. It's not images. So it's another form of analysis needed. And finally, or the fourth part here is mining text, because in the medical area, there are a huge number of new articles published all the time, and it's a big pressure on professionals in medicine to follow the advances through the publications. So a system that helps the professionals to explore all new information in from a publication by doing text mining of these is also a very useful system. And of course, this kind of findings could also be used to update medical expert systems as an indirect effect. I mean, the fifth area, as you know today, there are many experiments with surgical robots. And of course, surgical robots also have to be trained to do the optimal movements, the perfect movements. So training of robots, movements for surgical robots is clearly a case of the fifth category. So by this slide, I want to illustrate that it has some explanatory value, not to just say, oh, we have this fantastic application in medicine and it uses machine learning. It makes more sense to first to analyze what we're doing in one of these 5 categories, and then in the second stage say, oh, the image analysis is done by using machine learning. So this was the end of this lecture. I thank you for your attention, and the next lecture will be on the tutorial regarding the assignments for this week.